Hello students, welcome to my YouTube channel UPSU Technical Center once again. Today my subject is electromagnetic field theory and topic is rectangular coordinate systems. In this lecture I will discuss about the rectangular coordinate systems. If we represent a vector, how we will represent and what will be the coordinate presentation in case of rectangular coordinate systems, and next lecture I will discuss the cylindrical coordinate system, and the next lecture I will discuss the spherical coordinate systems. One important thing, and very important for the Macau students, you have the coordinate conversion from rectangular to cylindrical, cylindrical to rectangular, and it is equally true for rectangular to spherical, spherical to rectangular. That is the coordinate conversion. It is very important, as well as the vector conversion is very important. So to start this type of topics, such type of topics, initially we must know about the rectangular coordinate systems, and this structure here in this display, you will see that this is the basic structure or mother axis diagram, which is very important for throughout our lecture. So this is my x. You write it in the capital. This is y, and this is z, and this is fixed throughout our lecture. Throughout our lecture or next lecture, I will consider this will be the standard diagram. Okay, and this is O. So it is origin. You can write here. It is 0, 0. Okay. Now the representation of a particular coordinate. Suppose we consider a point over here. This is a point, and you just write down this is P point, and when you want to represent its coordinate, the presentation will be x, y, and z. You can consider x1, y1, z1, whatever. I have written over small x, small y, and small z. This is a three-dimensional presentation. So here presentation is x, y, z. When this is presented, that is x, that means some value will be in the x direction, that means in this direction. Y defines some value will be in the along the y direction, and z will define the some value in the throughout the z direction. Okay. Now we need to draw how we can present this. So we here is the diagram we can draw in the another color. What we have to do? Follow the procedure. What we have to do? From this point P, we have to draw a straight line. So this will be the straight line. Where you have to plot this straight line will be at the x y plane. This is my x y plane, and this is my x z plane, and this is my z y or y z plane. So here it will be the image of this point P, and you can consider this is P dash, and it will be same as x, y, and z. You can say, or as the image you can write x dash, y dash, z dash. It is not so much required. Next, first you have to draw a perpendicular on the xy plane first. Next we have to draw the parallel line from this P dash point, from this P dash point to the along x axis and along y axis. So first we draw the parallel line of OX line. and it will cut the z axis, well, sorry, y axis in a particular point. Suppose it is almost parallel. Okay. Next, parallel line of OY must draw from P dash, which will cut the OY axis, OX axis. Sorry, very sorry, OX axis. So first draw this line which is parallel with OX, it will cut over here, and another parallel line with OY which will cut the X axis. Now we have covered and we must mention the distances. So take another color. So here there will be some distances. So must remember what will be the distance. So what will be the value of this distance? Similar way, here will be some distances. What will be the value? Okay. Next, there will be some distance. Okay. It is very important thing. Then what will be this distance? You have to draw also the line. Okay. It is time consuming, but initially we have to proceed in such a way. Next, use this rubber and you delete this portion to for the betterment to understand in the proper way. Another dimension I have missed. Here is another distance from here to here. So what will be the distance? What will be the meaning of this distance and what will be the value of this distance? Use black color to mention it. This is XYZ. So here it is along the Y direction, that is the Y axis. So it will be small y. Similarly, it is a parallelogram. So it is y, so it must be y. It is along the OX axis, that means it is x. So it will be x. And it will along the z direction. So z axis direction it will be small. So this is our presentation. Okay. So in this way we can define the rectangular coordinate of a particular point P. Now what do we have to do? From origin, use again some another color. Use suppose use blue. Okay, so that will be good. From the origin, you have to draw a line to the particular point, and this will give you the actual direction from origin to this particular vector. This vector is called R vector or resultant vector, and also called R vector is called the position vector. Remember, it is a position vector, and you have to write down the expression of this particular vector. Another thing we have to remember, along the x direction there will be some unit vector direction. You can write it is Ix. Along the y-axis there will be some unit vector direction. It is Iy. Clear? And along the z direction it is Iz. You must clear about this. Similarly, along the r vector there will be some notation of the unit vector. You can consider along the r direction. This is IR. Now what will be the expressions of this vector? So this is xyz and this is 0, 0, 0. So what will be the expressions of r vector in rectangular coordinate system? You can put arrow or dash. So initially we have to move from 0 to 0. So the final and the initial, this will be the difference of this coordinate. Next, similar way you can write y minus 0, that is Iy. Next, you can proceed for z minus, that will be Iz, and in a simplified form it will be x Ix, y Iy, and z Iz. This is our presentation of a vector in rectangular coordinate systems. This is the representations of vector. You can write in another color. This is the representation of a vector R in rectangular coordinate system, RCS short. This is the presentation. Now what will be the modulus? We need to calculate the modulus. You have to take each components as a square and add up there. Afterwards the addition value you have to root. This is the mod value. This is the magnitude beta of a vector R. Now next important things, unit vector IR, how you can calculate. I know I have discussed, and you know the previous a few lecture before I have already discussed what will be the formula. Moder by modulus of. So this is the presentation. That is the representation of unit vector. Okay, and this is the in a brief way how you can remember, and these all things are very important. I think you must put some star. This much things you have to remember for numericals. So this is about the our representations of Cartesian coordinates and rectangular coordinates. That is another name also. Next, the product of this vector. Very important discussion. Product. Suppose I have an Ix vector. Suppose I have an Ix vector once again, and this is a unit vectors, and you have to do the dot product. What will be the result? Next, I have an Ix vector. I have an Ix vector, and someone tell perform the cross product. Okay, and this will equally true for the y vectors and z vectors. Next things, I have an Ix vectors and I have an Iy vector, and I have to do some dot product. What will be the answer? I have an Ix vectors, I have an Iy vectors, and someone tells perform the cross product. This is equally true for the other vectors also. Okay, so I will consider for Ix dot Ix, that is the cross product. No, sorry, dot product. Both are the same vectors. Both are directed in the along the same directions. So if I say what will be the angular displacement, as you know the angular displacement is 0 degree, and you know the formula mod of Ix mod of Iy cos of 0 degree. So mod of Ix, that is the mod value of unit vector, is 1. It is also 1. Cos 0 degree is 1. So answer will be 1. This relation is equally true for Iy, write down Iy. Similar way, Iz, Iz. So this is equally true for. Next thing, here the formula is mod of Ix mod of Ix sine of 0 degree. Here the angular distance 0 degree. Here maybe unit vector you consider any the some vector, normal vectors. Consider or not, no, nothing is there. Sine 0 degree is 0. So this is equally true for Ix, Iy cross Iy. This is equally true for Iz cross Iz. Understand? So must remember this. Must remember. Okay. This set of formula. Must remember. Next. Here. Ix dot Iy. Now the question is, look at here. This is the Ix direction and this is the Iy direction. Now question is, what will be the angular displacement? 90 degree. Similar way, if we consider another all unit vector directions, all are 90 degree to each other. So angular displacement, you can say angular displacement among the unit vector are 90 degree displaced with each other. Very important note, find it. Okay, so let's proceed. Here will be the displacement is 90 degree, and we know the same thing formula is mod of ix mod of iy, that will be 1 into 1 and cos 90 is 0. This is equally true for, you can consider iy, iz, iz, ix. We can proceed also iy, ix. You can proceed also iz, iy. You can proceed also iz, ix, iz. Why we can proceed? The conclusion is that I know the conclusion is that A, sorry, A dot B equal to B dot A. Follow the commutative law. So that's okay. Last one. Ix cross Iy. That will give you Iz. Very important. Iy cross Ix. That will give Iz. But in opposite direction. So consider minus. Look at here. Here is the Ix direction. I use this color. Here is the Ix direction. Here is the Iy direction. Now you want to multiply, that is the cross product. When you see Ix cross Iy, that means you can consider you are moving in this direction. When you are moving in this direction, then you will get your answer that will be in the Iz direction. Similar way, when we are multiplying Iy cross Ix, we are moving in this direction. That's why you are considering. Again, it is in the Iz direction, but here it will move in the downward direction. So this is the important notation you have to remember, and I have to read this color. Okay. So using this direction, answer is same, but the direction will be opposite. That's why you have to put here is a minus. Similarly, you can proceed for the other cases also. I have left this part for you to calculate and to gather knowledge about this. And if you not send my previous lecture, I in the case of cross product or dot product, go through this lecture, go through the playlist. I will provide the link in the description box. Okay. So this is all about our rectangular coordinate system. Next thing, you can say in the next lecture I will proceed the differential body of rectangular coordinate systems. This is for today's lecture. Next class I will discuss the differential body in case of rectangular coordinate system. Differential body, that will be the diagram, is very important, but for the Macau student this is not so important. So that's why I will just draw the picture and develop some formulas which is required for the numericals. Thank you students. Thank you very much for cooperating me. If this is valuable, kindly put a like, share to your friends. Those are new, subscribe this channel. Thank you very much.